All right, so we're supposed to find all the solutions in radians on the interval 0 to 2 pi for sine of 2x equals sine of x. Now, what tells me I'm going to do something different is A, I have a double angle, and B, I don't have a number I can just look at my unit circle. I can't just say, okay, find sine of x on the unit circle. That isn't one of our values. So the basic steps to starting this one off, I'll put it in blue, is first of all we're going to set equal to 0. Set equal to 0 and factor. That's going to be our goal. Now, factoring might not always be possible right off the bat, so we may have to use identities if possible. Identities if needed. So you won't need to use identities every single time, but especially when you see like this double angle, that's going to tell you we're probably going to need to use an identity. So if the first thing I do is set it equal to 0, I'm just going to write sine of 2x minus sine of x equals 0. Now, the first thing that tips me off is I can't factor because I can't pull a sine of x out. Because this is a sine of 2x. These are two different things, so there's nothing I can actually factor out. So that's going to tell you to use your double angle identity. So we're going to change that into 2 of sine x times cosine x. And you will have your identity sheet with you. So hopefully you can just look at that and get that part right. Sine of x. And we're going to make that equal to 0. Now we're going to notice that there's a sine of x in both of these. So that's going to tell me that's what I'm going to factor out. I'm going to factor out that sine of x. Let me go a little bit lower. I'm going to factor out that sine of x. So I just throw that in the front. And that's going to multiply by 2 times cosine of x, because I factored out that sine of x, minus 1. That's going to lead me to 2 equations. All right, I'm going to use the zero product property, which is basically if you have a chain of multiplications, you can set everything equal to 0. And that means that I can set sine of x is going to equal 0, or 2 cosine of x minus 1 is going to equal 0. One or both of those have to equal 0 in order for this equation to be 0. So now it's starting to look a lot more like the problems we did over the weekend and what we did on Thursday night. And I'm going to focus on each one individually. All right, so I'm going to make this a bigger problem than it really needs to be. But just for the sake of notes, we're going to do it. So I'm just going to focus on that sine of x equaling 0. Well, remember, when I say sine of x equals 0, what I'm actually asking for is x equals the sine inverse of 0. In other words, what angle am I looking at if sine equals 0? Now, I'm going to set that up every single time because you don't necessarily need this, as long as you understand that I'm looking for 0 on my unit circle. But when we get to things that are not on the unit circle, you're going to need to plug this in your calculator. All right, this one happens to be on our unit circle. So we're just looking at where sine equals 0, and we're going to list what angle that happens at. And if we went ahead and looked at our unit circle, we would see that sine equals 0 at 0 and at pi. So we're at 0 and pi. What I want to note is, hey, these are exactly 1 pi away. So either our x equals 0 or our x equals pi. Since they're exactly pi units away, we can write it as one equation, right? Because we can just keep adding pi. Because I can start at 0, add pi, add pi, add pi, add pi. So because they're exactly 1 pi away, we're going to write this as one equation. And we're going to write it as x equals Well, it's going to be 0 plus pi k, where that 0 kind of disappears because I don't need 0. I don't want to add 0. And I just put a little note because I see people not writing really notes while we're doing stuff. So I'm going to force you to write the note. Well, I'm going to write it at least. And I put since each is pi units away. And as I always say, what I write on here isn't always what you write on yours. You need to take what I say and put it on there. The people that do the best in this class have other notes, have other colors and stuff, because they need to go back and study it. Just because you get it right now doesn't mean you'll get it tonight, on Wednesday night, or when we take the final. All right? So the more notes you have on here, the easier it's going to be for you to study. All right, so we have just one equation. X equals pi times k. Well, I'm going to treat this all by itself. I'm going to look, where is this between 0 and 2 pi? Because at the end of the day, I don't want the equation. I want to know what actually exists between 0 and 2 pi. So we're going to look at it, and we can either look at our equation. Well, 0 is our first one. So 0, we're not in degrees, we're in radians. So 0 is going to be the first angle that happens between 0 and 2 pi. Pi is another one that's on there. 2 pi would be my, would I list 2 pi? Would I go over here and list 2 pi? No, I wouldn't list 2 pi. I would stop at 2 pi because of the, we have parentheses, not a bracket. All right, so there's only 2 angles that exist in that equation between 0 and 2 pi. All right, so we got this one taken care of. Good. Now we're going to look at the next one. So that is our 2 cosine x minus 1. So we have 2 cosine x minus 1. I want to have cosine all by itself, so I'm going to add 1 to both sides. Divide by 2, and we're going to see that we have cosine of x equals 1 over 2. But what I'm actually asking for is, when is x equal to the inverse of cosine of 1 over 2? In other words, I'm going to find 1 over 2 on my unit circle and tell me what angle that appears at. So if we draw our unit circle, well, you don't have to draw it, but you can just look at yours. Can someone tell me in radians, tell me where the first, just one, tell me the very first one where it equals 1/2. Yeah.
Pi over 3.
What was that?
Pi over 3.
Pi over 3, yeah, thank you. I thought you said pi over 2 for a second. Pi over 3. Now let's pretend I'm using a calculator, okay? I'm using a calculator and I know there's a second angle out there. Because there's almost always a second angle out there. The only time there might not be is if it's on the actual XY plane. But all the other ones have another angle associated with it. So our cosine answer needs to be positive. So I'm looking where cosine is positive. Well, cosine's positive here. It's negative here because we have all students take. It's negative here. It's positive here. So there must be one right here. Okay, there must be one right here, which you could find by doing 2 pi minus pi over 3. It's on our unit circle, so what does that come out to? Can someone tell me the other? Yeah.
5 pi over 3.
5 pi over 3, thank you. But we need to recognize that, hey, there's going to be ones where I put in the calculator, so I have to figure out how to get them. All right, that's how you get it. All right, now, either x is going to equal, is equaling pi over 3, or x is going to equal 5 pi over 3. Am I allowed to write this as one equation? No, they're not exactly pi distance apart. So we have to treat these as 2 separate equations. So we're going to say x equals pi over 3 plus, I need to do a full circle to get back to it, so I'll just say 2 pi times k. And another one's going to be plus 2 pi times k. Maybe I'll put a little note, this is 2 equations. since they are not pi units apart. And you can write whatever you want there or not write anything if that's your prerogative. All right, but you should have something down unless you just got it. I got it down cold. All right, so that means I have two equations to look for, and I'm still going to look for which angles are between 0 and 2 pi. Well, these make it really, really easy because we know pi over 3 is between 0 and 2 pi, so we almost always take that starting off value. If I add a full circle in it, I'm going to be way past 2 pi. All right, so I'm not going to add 2 pi to this one. I'm done with that one. My other one starts at 5 pi over 3. If I add 2 pi to 5 pi over 3, I'm going to go way past that 2 pi. So I'm just actually listing my two starting values. And it turned out that's what I did up here. And a lot of the times that's what's going to happen. Either you take just one value or two values. Some of them, if I take half, might be more. So just make sure you take as many as you can that are between 0 and 2 pi. So in that very bottom one, that's just where we're going to put our answer. We're going to put all four of those angles that we came up with. I put them in order. You don't have to. I'm not requiring that. So we have 0, pi over 3. We had pi. And finally we had 5 pi over 3. All right, so in effect, we didn't do anything new today. We just put together stuff we already knew. We know how to use identities. We should know how to factor. And we should know how to find angles. All right, because we did those in homework the last 2 times. So we didn't do anything new. We just put it all together. So don't try to do something new. Okay, don't overthink these. All right, we just have one more example to do. So we have 6 cosine squared x over 2 minus cosine x over 2 plus 2. My hint to you, especially if you're trying to factor them, if you're trying to factor these, is what I do with these is I go ahead and I let x equal that cosine of x over 2 because it makes it a little easier to write. That means I have 6 times x squared minus 7x plus 2 equals 0. There's 2 reasons why we do this. A, it makes it a little easier to write. This is actually factorable. I'm not going to factor. I'm actually using the quadratic equation. But if you get to an easy one, it's easy to factor as long as you have x's in it. And B, you're going to do a lot of this if you go to calculus. You're going to do a lot of substituting stuff in, where it's too hard to write these giant things out. So you substitute numbers in for easier variables, and then at the very end, you substitute your thing back in. Okay, obviously this is just a 6x squared minus 7x plus 2, so we could either factor, complete the square, use the quadratic formula. I just went ahead and used the quadratic formula because it works out really nice with the quadratic formula. So just a little reminder, a quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so we're just going to come up with x equals, negative b would be 7, plus or minus the square root of 7 squared, minus 4 times 6 times 2, all over 12, and you can figure that out on your own. It should work out to 7 plus or minus, I believe it's 1. Let me just double check in a second. It should be 7 plus or minus 1 over 12. Yep, got it. So that tells me either x equals 8 over 12, which is 2 over 3, or it's 6 over 12, which is 1/2. Substituting our cosine back in, we're going to say either cosine of x divided by 2 equals 2/3, or cosine of x over 2 equals 1/2. I'm going to start with the more complicated of the two, and that's going to be our 2/3. And that's because if you look at your unit circle right now, 2/3 is not on there. 2/3 is not a cosine value on there. So I'm going to start with that one because it's a little different than what we're doing. So in this box, I'm going to do my cosine of x over 2 equals 2/3, which I'm going to rewrite so I know what to put on my calculator. Is x over 2 equals the cosine inverse of 2/3, because now I can plug it in my calculator. I can't plug in this whole thing. I didn't have x even anywhere near itself. I'm going to leave it as x over 2 until you write your formulas. All right, you may want to put a note of that as we're doing this. You leave this x over 2 until we get to our formulas. So I'm pretending I'm treating this as it's all by itself. I'm just trying to figure out where cosine of -1 equals 2/3. And my advice is I would use degrees for these. I would use degrees for these to make your life a little easier when you're trying to subtract and add rather than doing by a small decimal. So I'm going to convert it to degrees, and if you plug this in your calculator, you should come out with 48.2 degrees, correct? Like I said, almost every angle you find is going to have a counterpart. It is your job to find the counterpoint. Your calculator will not tell you there's a second angle. So you need to think about where that 48.2 degrees is. Well, 48.2 degrees is maybe not that far, but I just want enough room to write 48.2 degrees. And that is where cosine is positive. What other quadrant is cosine positive? Because it has to have the same sign. Yeah. Quadrant 4. So that means my other point is where else it's positive, which is down here, which has two possibilities. Either we can just say it's -48.2. It will work. It will work. It's just not super traditional. I would like to have a positive angle. So you either can do -48.2 and add 360 to it, or you could just think about like this and just say, well, it's 360. It's almost a full circle minus that 48.2 degrees. Now remember, this won't work for everything. For sine, it would have been these two quadrants. For cosine, it's going to be these two quadrants. So that means either, based upon these two things, either x over 2 is going to equal 48.2 degrees, or x over 2 is going to equal 311.8 degrees, because this actually equals 311.8 degrees. If you just use -48.2, it would all work out just the same, okay? So if you feel comfortable just using negatives in here, you can. It's just more traditional to have that first positive. Are these exactly pi away from each other, or 180 away from each other? So I have to write two equations, right? So I'm going to write this as plus, rather than 2 pi, we're actually adding 360 because we're in degrees, times k, and that means the other one needs to be plus 360 degrees k. This is the step you solve for x. Don't multiply it here. Don't multiply it down here. As soon as you have k's involved, that is when you multiply by 2. So now we're going to multiply everything by 2. So we're multiplying everything by 2. And that's going to give me x equals 96.4. Why did I say 56? 96.4 degrees plus 720 degrees times k. And this guy, when I multiply everything by 2, is going to be x equals 623.6 degrees plus 720 degrees k. All right, now I just want to make a list of what of those angles I just created are between 0 and 2 pi. Instead of 2 pi, let's write 360. Let's leave everything the same. 360 degrees. Well, let's start with the first one. 96.4. That's when our k equals 0. That one works. If I add 720 to this, is this going to be less than 360? No, so that's the only one I can pull. Is 623.6 between 0 and 360? No, it's... What happens if I subtract 720? Is that going to work? What's 623 minus 720? Isn't that a negative number? Is that between 0 and 360? So how many more angles did I come up with? 0 more. That's it. It's just 96.4. That's the only one that works. Alright, so that's how you check these. Alright, you take your first angle that's between 0 and 360. You add whatever number's here and see if it's still less than. It's not. Then we look at our second one. Add, subtract. Neither of them work. So we're done with that one. That is 96.4 is the only one that comes up with that one. Alright, our last one we're going to do is that cosine of x divided by 2 equals 1/2. So we're doing cosine of x divided by 2 equals 1/2. Remember, what we're actually asking for is when is x divided by 2 equal to the inverse? Or in other words, what angle exists when cosine equals 1/2? Well, we already did these. The only difference between this one and that one is we're going to put these in degrees. All right, so we look at our unit circle, and we're going to see that it's at 60 degrees and 300 degrees. Try not to do one in radian and one in degrees. It makes things a little harder. So if I pick degrees for the top one, I'm going to use degrees in this one. So either our x divided by 2 equals 60 degrees, or our x divided by 2 equals 300 degrees. Once again, these aren't exactly 180 or pi away from each other, so we need two different equations. So we're going to have x divided by 2 equals 60 plus that 360 degrees to get me back. And we're going to do plus 360 degrees to keep going around the circle for that one. Once again, I need to multiply everything by 2 on both equations times 2. That's going to give me x equals 120 degrees plus 720 degrees k. And this one's going to be x equals, as soon as I see that 600 degrees, I know I'm not going to use anything out of that second one. Because 600 degrees definitely isn't between 0 and 360. If I subtract 720, that's a negative. If I add 720, that doesn't make any sense. So the only one that can even possibly work is this guy up here. Because once again, we're going to look at numbers between 0 and 360 degrees. Well, we know 120 is between there, so that's fine. If I add 720, that's 840. I don't think that's less than 360. If I subtract 720, that doesn't work either. That's my only answer for that one. So in short, we only came up with two answers, 96.4 and 120. So our complete answer is going to be 96.4 degrees and 120 degrees. Any questions on that? So it's just putting together stuff we already knew. All right, it is factoring. Where am I? It's factoring to set up two equations, and then doing what we normally do. We set it equal to something, find that on the circle, set up an equation based upon it. If they're exactly pi units apart, you should only have one equation. If they're anything other than pi apart, you should have both. All right, if you forget this, error on the side of making two formulas. Because if I didn't recognize these were pi away and I had 0 plus pi k and I had pi plus pi k, I would still get the right answers out. So error on the side of doing two equations. If you're ever just like, oh, was it if it was pi or not? Error on the side of doing two equations. It's not hard to keep track because if you can add pi, it's 1. But if you forget, error on the side of making two equations. Okay,